Well, good afternoon, and thank you very much for the invitation, and certainly thank you to SPNI and Yad Hanadiv for the invitation to speak here. And I will talk about fisheries, not from the perspective of the Mediterranean, although I've done some work in the Mediterranean. There's many other speakers here today who have had the opportunity to talk about this region, but I want to talk about other parts of the world, starting with a perspective on the world fish catch. And the most important thing to note, if you consider the recent world fish catch over the last 50 years, say, is that it has leveled off. If you look at this graph carefully, you'll notice that really we have not continued to increase the world catch for some years now. And that's not because people have not been trying to find new resources to exploit. It's not because people haven't been trying to produce more food. It's because we really have come to the limit of what the oceans can produce for human food, with some minor exceptions. You can rebuild stocks. There are some resources to discover. But by and large, the world fish catch has leveled out, as you see in the graph. It's not important, the distinction between the figures with China and without China. That's a really important observation because, of course, we have to ask, what does that mean for the food supply, not only in the Mediterranean, but globally? The reason that world fish catch has leveled out is because at least 75% of the stocks, as estimated by the Food and Agriculture Organization, are either overexploited or fully exploited. In other words, they are yielding as much as they could be expected to yield on biological grounds. And even that is a very optimistic figure because it only considers the major fisheries of the world, and it assumes that there aren't other factors such as climate change or loss of coastal productivity that is reducing overall fish productivity. So that leveling out is really quite an important and profound event in the history of the world's ocean. Of course, if you look at population size as shown in the light-colored line here, it is increasing, but the food supply in the dark line is not increasing. And the amount of fish that's used for non-food uses, some of that driven by aquaculture, quite a lot of it driven by aquaculture, is continuing to increase. That's in the lighter colored bars compared to the dark bars where the fish that's going directly for food use is not really increasing. So we've got a serious problem of not being able to continue to imagine that the world's ocean is going to feed the population of the world as humans continue to increase in population. And that's true all around the globe. That's not a Mediterranean problem. It's not a U.S. problem. It's both. It's a European problem as well. It's a Southeast Asia problem. It certainly is a Chinese problem. It's occurring in every region of the world to a very significant extent. So that's not a good message, and some of my colleagues, Enrique Sala and others, Elliot Norse, raised those concerns this morning, and I want to focus this in on fisheries per se. We are in some serious trouble with regard to productivity of the oceans, but I actually think that it is possible to recover, so I might disagree with my colleague from Israel, Professor Gorin. I do think it is possible to recover some stocks. And I do think it is possible to manage. And I also think it is possible to use lessons from other parts of the world. So I'm going to give you one of those in just a moment from the North Atlantic, particularly the place that I live and have worked on fisheries for many years. But first, if you look at the North Atlantic as a whole over the last century, you can see that there has been this substantial depletion all across the North Atlantic. So the warmer colors, the red colors at the beginning of the 20th century indicated higher abundances of fish. The scale doesn't really matter. By the end of the century, you see that we have significantly depleted North Atlantic resources all across the basin. And again, this is not specific to the Mediterranean, but is a very similar pattern, time shifted in some cases to what you would see here and in other parts of the world. Well, as I said, I live in the northeast U.S., labeled here New England. I used to be the fishery manager for the northeastern U.S. My region was from the Canadian border down to about the middle of the U.S. country. That's about 1,500 miles north to south, and then out to the west, out to the Great Lakes. And in the U.S. system, fisheries are managed by both the states and the federal governments, and they are managed through regional councils. That is, bodies that are set up to design fishery management plans for each region of the country, and those councils are made up of representatives from the states within a region and representatives from stakeholders groups within the region, mostly the fishing industry, but not exclusively. And the reason that it's done in this regional council setting is exactly what Professor Gorin said. You need to actually tailor a management plan to the conditions that occur within a particular region. I spent 5 years as the manager in the Northeast, and then 2 more years as a manager nationally, overseeing all of the regional management plans. And I can tell you that they are different in every part of the U.S., but they also have some important similarities, because the fundamentals of how populations grow and interact are similar, even if the species are different. The rates of growth may be different, the interactions with the environment are somewhat different, but there's a lot of common features. So while it's important to consider regional differences, it's also too important to consider what the fundamental properties are that you need to manage with. Well, if you think about, or if you examine the history of the Northeast region in the U.S., we see a pattern that, again, is remarkably similar to the Mediterranean. This is from some work that I did some years ago with colleagues at the University of New Hampshire. And 150 years ago, we estimate for one of the principal species, that is Atlantic cod, there was 1.2 million metric tons of cod within an area off the northeast coast. And that is down now to less than 50,000 metric tons in the population size. This isn't catch. If you look at the size of the fish, the average size one time ago was 20 pounds, now it's down to 6.5 pounds. This depletion pattern would be even more extreme in the Mediterranean, and is important to recognize that the potential productivity of the ocean was very much higher, unimaginably higher, even 150 years ago. From historical work that I've done with colleagues, including Enrique, in the Mediterranean, that's certainly true within the Mediterranean basin, the Western basin certainly, I think the Eastern basin as well from work that Enrique has done. So we've seen this same pattern of depletion, reduced size of principal species in the catch, and yes, of course, invasive species coming in many areas, including in the region that I worked in, down to a very, very small fraction of what that population was, even only a century and a half ago. Well, the recent history for fishing in the U.S. Northeast looks like this. In other words, we went from a population and a catch, this happens to be landings, of 3 principal species, and there were many more, but 3 of the principal species that was relatively large, down to a very depleted resource by the end of the last century. The vertical lines shown on this graph, the black lines, and then writing in between them, indicate different attempts to manage this fishery in a sustainable way. Originally, it was an international fishery. There was no exclusive economic zone out to 200 miles, as is part of the law of the sea now. But in 1976, the U.S. declared an exclusive economic zone, which resulted briefly in some rebuilding, as you see in the latter part of the 1970s, which was quickly replaced by overfishing of the resource by U.S. vessels, and a long depletion then for the next 2 decades, with many attempts to manage in between, at least up until the end of the century, as I pointed out. And a reduction from a very substantial fishery, again, for these of 3 of the principal species, down to just a few, well, really only a cod fishery and a little bit of other things. In 1995, actually the end of 1994, when I became manager for this region, one of my first tasks was to implement a series of closed areas. Now, the scale is obviously very different from Israel, but the principles, again, I think are the same. So initially, in 1995, the 3 large closed areas shown at the bottom of the chart were closed to all bottom fishing and all dragging for scallops, which is another important fishery in the region. But not all activity. So these were not no-take reserves. And I think, Enrique, you said that the Metis Islands was one square kilometer. So these are 8,000 square kilometers, so a little bit different in size. That's an important distinction, not because of the scale of the coast, but because when you have a no-take area, it's likely to be relatively small, because that's what will be possible to implement as a no-take area. But if you manage the different interests in a particular region, it may be possible to protect a much larger area if you can accept some activities. What does not work is to, as Giuseppe said in the other session, close an area only on paper. So when we closed these areas in the mid-90s, they weren't on paper. They actually were enforced. It's a very large area. It's enforced by making the penalties very high for violating the area, not by patrolling it with hundreds of ships. Another important feature on this graph is that you can't just close areas and expect to succeed. At the same time, the fishing effort was reduced initially by half and then even more than that in subsequent years, because it matters what happens outside the area, not just within any particular closed area. And the result is this in aggregate biomass. Remarkably enough, if you don't fish quite so hard, stocks actually do recover. This is for a group of stocks together. There's 19, I think, included in this particular graph. I like it for a number of reasons. One is because the time point where the blue line is when I became the manager for the region. There's 2 lessons from that. Always use the graph forevermore, but secondly, it's always best to start at the bottom because you can only do better. But more importantly, that if you implement a set of strong management measures, the biology does respond, the ecosystem does respond. It's not as if there are not other factors, including invasive species in this region, but fishing pressure is a major factor in any case. It is never without controversy. This is in the town that I live in now, Gloucester, Massachusetts, a demonstration in Gloucester Harbor against fishing regulations, even though catches were going up, because, of course, the fishermen wanted the opportunity to catch even more. And I'm actually in this picture. I'm one of the people hanging from that boat in the back, which I also always use in every talk because it's a proud moment. A lot of people were very angry, but also the catch was increasing. So you can't expect these things to happen without controversy. And there was a question in a previous session I heard of why don't fishermen accept that their catches will go up? And there's a simple reason. They have to get to the point when the catches will go up. They still have to make a living until the point where the catches have to go up. And they have to believe you that the catches will go up. And so it always will be a very controversial problem to implement these kinds of rules. But when fishing pressure is reduced, if you look across stocks, these happen to be U.S. stocks, but have also done the analysis around the world, you do see recovery, not only in catch, but in the biomass. So in each case, the red line is fishing pressure, the blue line is the stock, and you can catalog any number of resources where you see real recovery. So in conclusion then, recovery of overexploited stocks, even after a very long time, is possible. It doesn't mean you'll go back to some picture of 150 years ago. Again, I would certainly agree with Professor Gore on that point, but it is possible to achieve some significant recovery if you manage the fishing pressure appropriately. Yields will increase slowly, and you have to expect that, and therefore you have to manage that interaction and not expect that people can just easily live through it if they make their living from the sea. I believe that closed areas, and yes, fully protected marine reserves, can be a key part of that strategy. In a small coastline like in Israel, I believe that marine reserves are essential. That would also be true in a much larger area, but particularly here, for monitoring reasons, for habitat reasons, as well as for overall reduction in fishing pressure. But I also believe that you must directly control catch and effort in almost any fishery system unless you're going to implement extremely large closures, and that's not practical in most places because of the dislocation that results. So I do believe that it's possible to manage fisheries and to improve both the resource and the yields from those resources. I think that's possible in the Mediterranean as well as in the regions that I've worked. Thank you very much.